Welcome everyone on this new episode of Let's Talk AI. Super happy to be here with Médéric Hurier. Médéric, how are you doing?
I'm fine. Really excited to be there, Thomas.
Likewise, I'm super hyped about this episode and I have many questions. Just for everyone who is tuning in, Let's Talk AI, the podcast where we deep dive with experts about data and AI. And we just have in-depth discussions of careers, tips, vision, what's going on in the field, latest papers, and so on. And today we're with Médéric. Médéric, for the people who might not know you, could you maybe introduce yourself in a few words?
Yeah, sure. So my name is Médéric Hurier. I'm 35. I'm currently working as a freelancer for my customer Decathlon, and I work in a position of Lead MLOps Engineer. So my task involve helping others in deploying their AI ML system, trying to define which component to use, what are the best practices in terms of deployment, in terms of development, and yeah, try to be involved on everything that could make the life of data scientist and ML engineer easier.
Hmm. And this is what we need right now,
Yeah,
making our life easier.
yeah,
Okay, so just maybe for everyone's to get to know you a little bit better. You mentioned Decathlon as your current client, but what are you trying to achieve right now in the field, or what are you focusing on? What are your interests at? If I were to ask you a bit about the state of the art of Médéric, like
yeah.
what would you share with me?
Yeah, so I think what I like with MLOps is that it's a really stimulating thing, but that's not something I found firsthand. It's for my background. I started as a web developer, a security engineer. Then I move on to do a thesis and become a data scientist. And from all my background, I found interesting something that interested me more than others. For example, working on system administration on Linux on Docker system or and on the technical stack, automation and data science also spark my interest because you have to combine mathematics, model, some advanced subjects, and when you combine the two, that gives you MLOps. So it's a field that's cool. You build incredible stuff. I mean, I'm always amazed by how my colleague speak about their project with such passion and what it can do for others on logistic and so on. So for me, the objective is to try to ride the wave. I mean, it provides values, it's stimulating, and you can find a lot of interesting projects. So if you have all of that, I think that's perfect combination.
Awesome. That's your state of the art. Makes total sense. So if that sounds good, I'd love to make a quick retrospective on
Uh,
like key moments of your career. So could you share maybe the main things since university, or like what are the key moments and maybe some lessons that you can share with us along the way?
Yeah, so I had a complex background, but I think it's retrospectively it's interesting. So I started, as I mentioned, as a web developer, as a
Mm-hmm.
PhD developer, and so my task was to code PhD every day. I mean, it was fine. I could make a living out of it, but it was not the most stimulating.
Yeah.
So I went back to university, complete a master's degree, and I work in security engineering, really interesting stuff because you have to always fight the bad guys. People in the field, they are always trying to find the hackiest way to do stuff. Yeah, I invite your listener to go at some point to a security conference. It's really amazing what you can find. You see how can people exploit things like that. I mean, it's incredible. And so I really love the field. And for my first job as a security engineer, I work in a big bank called Clearstream. It's a kind of bank of bank, if you see. And my goal there was to collect all the log of the company and to try to find insights. The system was called a SIM. It was Security Information and Event Management. So the goal was to collect every log of the company, firewall, IDS, Linux system, everything, and try to find breaches, incident pattern in that. So we had to collect a terabyte of log every weeks and to analyze them. And that's where I found, okay, I think there is really something interesting there. It was the era of big data. The most trendiest thing back then was Hadoop. And I thought, yeah, I really like managing this kind of huge amount of data. you have a visibility on everything in the system. You really feel like you are touching the brain of the security of the IT security. And yeah, it was a really interesting project. The only thing is, I mean, at that point I was 25 and I thought, yeah, working in the bank, it's secure, it's fine, but it was a bit too not the most stimulating thing. So my colleague told me, Médéric, you should do a PhD thesis that's even more stimulating, So I went to do my thesis at the University of Luxembourg, and I collaborated with Google, and my goal was to work on detecting malware with machine learning system, which for me combines the two things I like the most: computer security, machine learning. And yeah, it's to move the field. There's so much to be done, still many things to be done right now, I think. And yeah, it was an interesting thing.
Wow, that's very impressive. How many questions? We'll deep dive into different of these subjects that you just mentioned. I'm very curious about technology. I really want to ask you also about coding principles and like well, basics, different interesting things that we'll come back to. You mentioned your thesis, so I'd like to maybe linger a little bit on your PhD. So you mentioned that you did it in collaboration with Google. Can you maybe share a little bit further what was the thesis about? How was it to go from a bank to a PhD? Like your colleague told you that it would be a stimulating experiences. Was it a stimulating experiences? And like, do you have some insights and maybe share your the conclusions of your work?
Yeah, so to give you an example, so when I say when you people are looking for something stimulating, when I work on the SIM system, at some point I say, it would be so nice to have a system to send a log to other system. So at that point, I read the RFC for the syslog system on Unix and
Okay.
implementing my own thing on Ruby. And that's where
Okay.
my colleague told me, Médéric, when you are doing this kind of stuff, you should definitely do a PhD. It's this kind of stuff. You read the RFC, you do, you try to experiment with it. So yeah, I move on to do my PhD. So in the beginning, the Android malware was a big topic. Mobile, it's really used nowadays,
Okay.
and still is now. And so the thesis, at first, what I thought was to use machine learning with deep learning, XGBoost, and so on to detect malware. But
Yep.
when I came in the domain, I realized, oh man, there is just so many people that did that. People from big university, from
Okay.
Google as well. And when you discuss with Google people, they tell you, yeah, we have tons of model. We are Google, so we have tons of good model to predict stuff. So I thought, okay, so yeah, doing machine learning might not be the best thing. So what I ended up doing is to try to work on the data, because I asked experts in the domain, okay, what you are trying to do to predict malware, and what is
Hmm.
a malware? And people told me, yeah, malware. It's so maybe you're not familiar. We have this tool called Virus Total. It's
Yep.
a system from Google which gather all the antivirus in the world
Okay.
and give you the rating for each. Like you give it an Android malware, an Android application, sorry,
Hmm.
tells you if it's a malware and which family.
Okay.
We use that, and people in the field were saying, yeah, if the system says it's a malware, then it is a malware. But why? Where is the payload? What the malware do? You have nothing. It just this is the malware of this family, like Kugyo, Adu, and so on. I
Yep.
thought, yeah, but it's kind of bad because some antivirus say it's a malware, others don't.
Hmm.
Some system they don't agree on the name. So what's going on? And people told me, yeah, but we are researchers, so for us that's fine. You have a system telling us it's a malware, so we can do machine learning. We are fine with that. And
Okay.
so I decided to go deeper and to on this thing and to create proper ground truth for malware. For
Okay.
me, this was key because I think if you don't understand your ground truth, what do you predict? Is it good? Is it bad? How can you judge? So it was not the most, I would say, exciting task, but it was the task that I feel was needed the most in the field. So
Hmm.
my group managed a system called Androzu. They were managing 8 million Android applications.
Okay.
So it was in a scale of petabytes, so a lot of Android malware. And I took this malware, and through my thesis, I tried to understand how what is the malware that you have in a way. So I took the antivirus label from Aristotle,
Hmm.
analyze them, try to find, okay, what are the recurring patterns, how we can say is it really a malware or not. Then I came up to a new algorithm to take all these label, put them in a graph, an acyclic graph, and try to map what are the relationship between them. So it's similar
Okay.
to what you have in NLP. You see when you have
Mm-hmm.
occurring terms. Here it was with malware names to try to summarize. Okay, which are the key family?
Mm-hmm.
To find the synonyms, to find the things which are related, the one which are not. And in the end, my last paper was taking the whole database of Android application that we had, extract all the feature I could find, so the strings, the class name, the files in them. So you name it, I had billions of features because everything could be a feature. It was like, do you have this string? Yes or no. So everything could be a characteristic, more
Mm.
precisely. And I run an algorithm similar to TF-IDF you see in NLP. So to say, okay, you have plenty of things which are commons, like
Mm-hmm.
you can say, for example, in ML project, every project has pandas or sklearn, but
Mm-hmm.
some things are more singular than others. And the
Yes.
goal was to highlight the singular thing and associate them within the family. So, for
Okay.
example, you take the Hadoop family,
Mm-hmm.
and you realize, okay, there is this class, it's only present in the Hadoop family. And so I extracted all this code snippet and all this thing, and I could say, okay, giving this family, these are the core characteristic that are singular to this family, and people could pin to go on this feature precisely on this code snippet to find, okay, to analyze the system. And so I
Okay.
ended up presenting my work at Google. It was a great experience, but yeah, a PhD can be a lot of difficulty sometimes. So, but I can come up on that if you want.
Wow. That's very impressive. I have one question on top of
Yeah.
mine, but I'll keep it for after. And what was the feedback of Google, and what did the PhD um like? What did
What
you
amazing.
learn during the
Yeah.
overall experience? Not only in terms of conclusions, but like just going through the process of pushing the limits of the field and presenting to Google. Like, how was your overall experience? What was the feedback? Can you share a little bit on that?
Yeah, sure. So I think the first thing is I think a PhD is the best way to feel both incredibly dumb and to feel like a god because you are jumping from an emotional state where you feel like you are a failure, you cannot accomplish anything good, and you are you will quit the PhD from oh, I have the best idea and I'm just eager to implement it. So it was this
Mm.
constant zigzag of emotional states. Um, what was key in the PhD for me is first I learned a lot technically. That's something I was really looking at. So I had to manage 15 terabyte of data.
Yeah, this is my next question.
Yeah,
like
so
how like how do you like write algorithms at such a scale? Like how do you think? But we'll come back to it, or maybe
yeah,
you want
so
to
it
comment.
depends the most interesting thing. I think it's I had to manage 15 terabyte of data, but not with
It's
a
wild.
cloud. It would be
Yep.
too easy in a cloud,
Oh
just
yeah, I
no,
can imagine.
no, no. So we had PC towers, like the one you use to play games, at
Uh,
home. We have four of them, and okay, my challenge was how can I scale my algorithm because it was really the main struggle. I think I tested 20 databases from graph database like Neo4j, Titan Graph, Janus. I tested so PostgreSQL, MongoDB because I had a particular pattern I like to have. So to explain, you have applications. Naturally, you can say for this application, I have this characteristic. Now, opposite question, I want to say I have this characteristic. Give me the whole list of application that are related to this characteristic. So
okay.
since easy, it's like you have sparse matrix. It's like doing a transpose. It's incredibly hard to do at scale. So you can do that maybe on some system, but I have
Yeah.
I have millions of applications, billions of features, and it was a key challenge. And so I ended up doing, I think, for me, it was at some point, it's like you throw it at the wall, you see if it sticks. So I said, okay, let's try Elastic. Elastic work, perfect. I can use Elastic. So I created the cluster, distributed on the system, trying to run my computation on that. To give you an example how brutal it was, at the end of my thesis, the sysadmin, the system was freezing. So we didn't reboot the server, so the system was completely froze. We asked the sysadmin, can you please restart the server gently? So what did they do? They just hard reboot the system with the
Aye.
cache, everything. I said, oh man, I'm just 3 months before the end of my thesis. Please let me. I beg you. I want the server to be up and running. So it was up and running. So Thanks. And yeah, so it was everything we tried to scrap things because the university, they had a great computing system, so a lot of CPU, RAM, and so on, but in terms of disk, of IO, and I think
Mhm,
that's something that you may also experiment in the field. It's not necessarily the thing you think first, like, okay, you have a big NVIDIA card. It's how do you use it, the network, the bandwidth. If you have a bad network or bad disk system,
mhm,
for certain patterns, it doesn't work.
mhm,
So yeah, it was really interesting. So I had to develop a lot in Python. I work a lot on best practices. And so coming to Google, in the end, when I proposed the last system, I say, okay, so my algorithm, it's a bit naive, I would say, but no, it's doing this TF-IDF, IDF, transposing the matrix and so on.
mhm.
But they say, yeah, but at this scale, so they use BigQuery, and they told me, okay, the approach is interesting, but BigQuery doesn't, work for us. It's just too many features. So I say, all right, you have the same problem as me. So if some of your listeners has a good database or technology, if some have after 5 years, I'd like to know, please, because it was my main struggle during my PhD. And yes, so in the end, the approach was interesting. It was working at small scale. One paper down the line, I could have created maybe a better algorithm that work in this case. But it was the end of my PhD, so I said, okay, research is, I've done my part. I want to move back to the industry now. So yeah, that's how I left the academia.
Wow. Amazing. I want to ask you many questions on yeah.
One last thing, just the funniest thing. Do you know how I end up doing this kind of inverse into this transpose? I tried everything.
All
In
right.
the end, I took 3 hard drive of 2 terabyte each. I compressed the whole data on one disk. I use the other as a cache, and the last one as an output. And I use GNU sort.
What is
It was the
Grisart?
only thing I could scale because I say, okay, just doing a sorting algorithm. So at this scale, okay, it's n log n, and the memory was okay with the cache disk. So I tried everything, but with the overhead of distributed systems, so nothing worked. So in the end, the only thing that worked in my case was hard compression plus using GNU sort, and it was the best thing. So uh, overall, a lot of hacky stuff, but really interesting because you really, you hit the wall so many times that you really know then how to handle and understand data system.
That's very impressive. Like, I would have so many questions. I feel that we could just discuss that during the entire episode. Um, how did you feel when it worked, when your hacky solution worked, and how many days did you had left before the end of your thesis?
So yeah, so in the end I work on 3 papers, and this last one was 9 months before. So at that point I say, okay, this one is done. I can close there and write my thesis because
Hmm.
writing a thesis is a lot of work. So I'm
Yeah,
doing a bit of blogging, on writings, and writing, it's like any training muscle. You need to practice, and writing the thesis, when it's really something I wanted to have the time to do that, and maybe if I had spare time doing other things, but yeah, try to be prudent about the what to do there.
all right, makes sense. Um, Very interesting. So you said
Yeah,
Elasticsearch was the
yeah,
database that you stick with.
exactly. Yeah.
Uh, Wow. What did you learn trying so many databases? What did you learn? Because so many times I feel like, let's say, I mean, it's not every day that we are going, it would be recommended for one personal interest, but it's not every day that we have the opportunity to just try all the databases with a huge amount of data.
Yeah.
So, what have you learned around this part of your thesis? Like, do you have insights on databases? What are they good for? What are not? Or is it like very focused based on the problems that you had and you were just going through one? And
Yeah, so that's a good question. So I will come back to it, but just to also give some context. So at university, I was also responsible for the course on big data, and it
okay.
was a really interesting experience to explain things to your students, test things by the theory, in the lab, and noticing that the theory doesn't always work. So yeah, so I could explain, okay, graph database, document database, NoSQL, all the trade-off that people do. We are joking with my colleagues saying, okay, when you have a benchmark on SQL database or NoSQL, some researcher, they like to say, okay, let's do something like remove the fact that you're writing on disk so we can improve the benchmark. So let's try to remove the acid properties or removing. So at some point in the database, you say, okay, if there is a power outage, nothing will, will remain of your data. So, but yeah, so there was a lot of excitement in our group. We were discussing a lot about databases with one of the company working in Luxembourg, so data things. So a lot of interesting discussion. And in the end, I don't know how to say that, but what you realize is what matters is the concrete implementation. You can have the best model of how the database should work, which thing it's good at, but it's really the structure and the how people created it. I give another example. Like in my thesis, something I enjoy learning was Clojure and Haskell, so two functional programming languages. Something you never see in the industry, but for some reason in the academia, I think at some point, if you wrote Clojure Lisp compiler in Haskell, you say, okay, I'm really living the
one of
paradise with my thesis.
one
So
of the few.
yeah. So in functional programming, you have a nice of good properties. People call it's very pure languages and all this concept and all that. I really love that. What you end up finding in practice is that nothing beats C in terms of raw performance, and you have always this struggle where personally I really like functional programming. I did most of my thesis with Clojure, a Lisp language, because you have a high level concept you can really handle, manipulate. So based on non calculus, and you like this high level thinking on one end, but when it comes up to raw performance, you trust that somebody wrote it in C. And that's the same in the data science ecosystem. You have Python. It's not something you will think, yeah, why Python? It's not that's fast. But you say, okay, some people created a C implementation that's really performant. That's why it's working so well. So same for
Mm.
database. You want to use to not have to go deep into the details if possible. At some point you have, and reconsidering my thesis, creating a key contribution to Elastic just to be able to retrieve some index and work on some stuff. But yeah, at some point it's okay, calm down. If you go to this rabbit hole, you will never come back. So try to just say, see what sticks. That's the best.
That's interesting. Um, could you share with us maybe like how would the database look like when you work on a specific problem like the one you described? So you have all these applications and you have all the information related to them, and you try to find like how malware could attack them or if they contain malware. I'm not sure if I'm framing it well, but how would you um, like how would you go about like data modeling part, or how does it look like? I'm not sure about how to think of it, so maybe if you can share a bit with us some insights on how do you build a database around this kind of problems with this kind of data.
Yes, the answer is too simple. So let me just explain a bit more. One of my teachers used to tell me, a good database manager, you need to think of its data, normalize it, implement it. Then you notice, it's not that fast. Then normalize it, and then he has a good version. So what was the schema? A big, big, big JSON document on one
Okay.
database, and that was it. And it was just like, for example, you had one JSON for all the component, internal component, like the strings, the code snippets, method names, the files inside the APK. So an APK is like a big zip file, so you can index all the stuff. You have to extract it first, index it. And once it's indexed, you can compute a lot of metrics like what is the average number of line per class, what is number of executable file compared to the other file, and so on. And so every database, what's like this kind of huge pieces, but no normalization. You're not allowed to do that. It's just not performant enough. So it's performance by brute force. And I
Hmm.
know some company, for example, I discussed with, I cannot say the name, but they tell me they are managing a big, big Elastic cluster, and all they do is writing Java program to move things around. So the database is really performant, but they cannot use this normalization feature that you like joins and so on. So everything is written in Java, and that's how they achieve the best performance. So yeah.
Wow. All right. Oh, that's interesting. All right. So That's about such an interesting work around your PhD, but then you've worked with companies, just to give a few names, Google, BNP Paribas, European Commission. You're actually working at Decathlon. So I have two questions. I think we'll start from the second one, which is academic versus industry.
Yeah.
What led you to move from you finished your PhD, now you want to go to the industry and not stay maybe in a more academical path? And like, how do you balance both of them? What are the pros, the cons? How do they combine together well? Do you have insights on that?
Yeah. So the thing is, so like something I used to say, it's I love learning, I hate school. I love research, I hate academia. Just to say that I love the activity, but I know how it's structure and frame, because I think there's more thing to optimize. So the main issue I had with academia is that I worked in the industry before, and I was too concrete. Like every time I was working on something, I say I need to have an open source software with unit test. And my colleague told me, Médéric, unit test in research software, just no ways. No, people just don't care. Just write the paper. No, but I need to read it in open source with documentation and readme. No, do something. And everything was like that. So what I enjoy the most was to create all this software. And academia, what it gave me, research, what it gave me is this ability to let my curiosity went loose. Try to work on activity which I think adds the most value to the ecosystem, and not necessarily thinking, okay, just need to be useful, not necessarily to sell it, because that's the hardest part in building a product, but to do something that's useful. And it's yeah, so it was nice on one end to be able to explore the field. I did a ton of MOOC, of courses learning about databases, so it was a great journey. Like you go around the world, you testing things, like it's like discovering all the food possible. But you end up saying, okay, that's nice, but doing that all my life. And plus, as I mentioned, academia, so you have to think after that about proposal and paperwork and things like this. So I think it's good if you are really into this kind of constant exploration mindset. Um, if at some point you want to build something useful, I think there can be some struggle. Not some universities do more better than others. And yeah, so for me it was clear. After my PhD, I had this time to explore and to nurture my skill in data science and big data. So I wanted to apply it on concrete projects. In the end, I enjoy working more with companies like ArcelorMittal, BNP Paribas, European Commission, Decathlon, in the end, than to say, okay, I will spend 5 more years in academia and doing on paper that you go to the conference, some people read it, but I think it doesn't have the same impact from my perspective. But again, really personal. Some people stay in academia, they love it, and I think it's that people are different, and that's the key thing.
Hmm. That's interesting. I always love to ask this question and hearing about academia versus the industry. And I feel like the more when we reduce the gap between both, the more we make it easy for people who are more on the academic side to contribute to the industry, and vice versa. I feel that it just creates a better outcomes. Like we can see a lot of those LLMs. Just to give one example, but
Yeah,
a lot of the LLMs, when we just go during a long time to optimize based on a specific framework, on a specific lost the word, benchmark. when
yeah,
when you try to optimize like specific benchmark, but you just tweaked a little bit your data set, or
mm,
to me it's okay. I'm not saying in academia there are no, like I feel that, my point is combining both and like having um uh, communication and bridging the gap between the two fields seems to me key in the future, or
yeah,
at least how we think of like the words we use in both. I don't know, I just feel like bridging the gap somehow. I've had this discussion before like many times, and I feel like this is something very valuable, because when we're able to discuss between industry and academia, it's where we can really be more productive and find better solutions. So I think there's something here interesting. um
Exactly. But the main difficulty, I think, is to have people that understand each other. I think maybe you've encountered that in your career. It's a data engineer. It's uh, you have people, for example, they are really good at development. Data is another field. People which are building the UI, it's yet another one. Business, I work with geostatistician, people from the bank. So, um, and it's hard to find, a common vocabulary, common practices, and so on. So, for me, I think there is a gap. So again, it depends on the country. Some country, they are more okay. The two should be kept separated and so on. So for me, I agree. For bringing the most value, they should collaborate. But is it able to mix? It's like a water and oil. Sometimes you say no. Sometimes it's hard, and you need to have a master chef able to make the right sauce with the two. It's not like, for example, BNP Paribas. When I work at BNP Paribas, we had some two PhD students working there, and the customer with a business problem. For several months, it was difficult for them to find, okay, what things is best tackled by academia, which things are best tackled by the industry. Like, for example, building Docker, which one should do that? So it's and when I contributed to this mission with BNP Paribas, my task was to try to understand the expectations from each one, try to find the boundaries between the two, so that every people could enjoy the work and not and it would work well. But I think out of the box, if if for example people don't know how the other side is working, it's difficult. But since I had a background in the industry and in research, it was easier for me to bridge the gap in this project, for instance.
Hmm. Yeah, I feel like sometimes we try to allocate the resources correctly when we just need to like build a team of different profiles and they have all the same goal, and they just balance one another with like their unique skills.
Mm.
And ideally, in a team when some people are not that expert in one field but have like multiple skills, or like can serve as a load balancer because they can
Mm. Yeah.
traduce what one side is saying to the other. I feel that those are very interesting skills, and I
Mm.
feel like more and more profiles are growing like that, but we're still like lacking of these profiles that can perform in like different environments, like understanding users, understanding business, but also understanding like the problems and what they
Mm.
imply and what's behind it. I feel that those profiles are very interesting.
Mm. I agree.
um I'd like to ask you about freelancing and
Mm.
Decathlon. So you're right now working with Decathlon.
Yeah.
All right. What can you teach us about freelancing, the journey of a freelancer, and do you have an experience to share at Decathlon, like a project or 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 any client that you had in the past also, but like an end-to-end project that you find particularly interesting and had fun building?
Yeah, so it's a good question. Actually, the two questions I get the most from people I know on LinkedIn and MLOps community, it's how to become a freelancer and how to become an MLOps engineer. So, all right.
Two in one.
The secret sauce.
Yeah.
I think so. The first thing is to be sure it's in the equation of your personality. I think
Mhm.
being a freelancer, it's to have an unbounded curiosity, always trying to push the limits. So trying to stay state of the art, trying project on your own. It's to also try to know what people are doing in the field. So not to be alone, sitting in your room, but you need to also to meet with other people. So that's why, for example, I started the MLOps community in Luxembourg, is to meet with others, try to see what's their problem, what's their feedback. So for me, after academia, you have a tag like academia. So first thing first, you try to get rid of this tag. So I went to a consulting company called Sphere, a good company. I really enjoy working there, and I had the opportunity to work with the ArcelorMittal and Decathlon there. And I learned a lot. So first mission was as a data scientist, trying to optimize pricing model for ArcelorMittal for their steel product. And then for Decathlon, my task was to implement the new MLOps platform. There is a gap between the two, data scientist and engineer. So what was happening is I did a certification on becoming a professional ML engineer on GCP, and I was fortunate because 3 months later, Decathlon was looking for someone with this skill. So they say perfect. It was brand new, so I was in the beta user. They say okay, there may be 100 people that have this certification, so we are happy to have you on board. And so I ended up doing the GCP platform. And then they asked me, okay, do you want to continue working? You have also the AWS platform to do. So I didn't know nothing about the AWS cloud system. So what I ended up doing, secret sauce, I took the whole SageMaker documentation and read it over a week with all the white papers, all the architecture blog, on their website. It's a bit like Neo in Matrix. You upload Kung Fu, so you upload the SageMaker in your brain, and you say, okay, I know Kung Fu, so it's a thing. It's databases. When you know MySQL, you know Postgres. There is a bit of feature on top, but it's the same concept. MLOps platform is the same. So yeah, it's one thing was to answer your question. One thing is I think it's important to be curious. Try to stay of the art. We need to be. I'm sorry to say that, but try to be on top. For being an expert in something. You don't want to have a freelance. From my perspective, at least, it's that may not be as accustomed to the field. So you need to grow your skill, work on interesting projects.
Yeah.
You need to market yourself well. So personal branding. Working on other projects, trying to be to share with the community as well, to build the relationship. And then yeah, there's nothing much more, because I think in our field we're quite lucky. I mean, I receive messages every week about, hey, do you want to work as a Python developer, ML engineer, data scientist? We don't have to look that far, I think, to find the customers once you have the experience. But it's really the two things: the skills, then comes the experience, and then comes the freedom and the money and everything. But it's the skill first, and then everything goes from there.
Love it. Amazing. You said very. You said too many things. My mind is like, oh, um, I mean, not too many things, but like I have too many questions right now.
I have time
Um,
if you want.
um, all right. Um, Decathlon, freelancing. I'm going to ask you again about like building around an MLOps,
Yeah.
like leading an MLOps project. Um, I find the pricing models interesting. Maybe I'll ask you about that. But you said something very interesting, which is we have a lot of opportunities,
Mhm.
but skills first. All right. First of all, it feels that once you've made the work to master concepts, which you
Yeah.
kind of did
Yeah.
when you
Yeah.
tried all the databases and so on,
Exactly. Yeah.
I feel like the further you get into a field and the further you get into concepts, the easier it is to learn something from scratch, which
Mhm.
have like, because ML engineers is or ML ops, it's just like the basis are like software engineer plus data science plus different things, but like you already had all of this, and so it feels like this is also why, even though not easy, but you were able to in 1 week just go through everything and like, okay, get it, I understand what's behind it. Do you want maybe to linger on that or comment or add something?
Yeah. So I think it's really important because the key thing, it's like reinforcement learning. There is
Yeah.
always this trade-off between exploration and exploitation. I think
Mm,
every moment in your career, you have this balance to find. Um, and every moment you still are exploring stuff. So after my PhD, there is something I didn't knew, so you are still learning. You start, for example, learning about like XGBoost. I use XGBoost a lot at my time at ArcelorMittal, so I really went so deep into this system, but at the end, okay, I know it by heart. But before that, we are using different system at the
mm,
university, so it's and then you can exploit the thing that you learn. For example, how to structure a code base and so on. So yeah. And so coming
mm,
to your question about MLOps platform, so the, the key difficulty, I think, is to take things in the right order. I think it really helps to have some kind of to be structured and to try to engage with the customer. My manager at Decathlon, I really love him, so I say hi if he's listening. He tell me, Médéric, MLOps is about change management. And when you say it like that, you say, okay, it's a human process. It's something where you need to communicate, explain, and again, coming I love teaching, so okay, change accepted. Call me old school. My work, for example, involve using, for example, UML. So it's Unified Modeling Language. It's old stuff from the ages, of IT. But the thing is, the first thing was to map to interview people. Say, what's your problem? Second thing, what's okay? Let's try to come up with some use case. So you need to train a model. You need to tune it. So just to be sure that you are in line and we communicate what we expect from the platform. And then you say, okay, we need some logical component to do the task. You need to have some compute system, some storage. So that's obvious, but you need to think about also about the tracking, about for example, the orchestration. So you have all this layer, and then you say, okay, I need now to find the technical solution to implement them. So you say, okay, there is what? There is Airflow, there is SageMaker, there is Vertex, and so on. And there you say, okay, these systems are quite complex. I can learn a lot from them, but experience from university, you need to have first-hand experience. You can, if you just believe the theory, sometimes it doesn't stick on the wall. So you you try the technology with others. You get their feedback, really important. To give an example, you could say, okay, I'll do that. I'm working alone. I will take this system, test them all by myself. But then you came up in front of someone, say, okay, use that, and the people rightfully will say, why? What is this thing? I don't know what it is. So one of the goals was to bring people on board to spend time with data scientists, to let them test the platform, guide them, and so on. So in the end, you have what people want, the real thing that matters to them,
Mhm.
the use case, logical component, the solution, which solution is best, and then you just need to make some glue around that, and you have an MLOps platform. It sounds easy, I think, but the key thing, and that's a common topic, it's really the human aspect. Bring people together, let them engage. We had this concept of champions, people we thought was really interested already by the concept of MLOps. We say, okay, we can base on deployment adoption strategy on them.
Mm.
And yes, so it was a very interesting missions.
That's super interesting. And I feel that a lot of the time, um, the problem that we can face, we can build the best MLOps system where like it's super easy to build use
Mm.
cases and deploy them very fast and so on. But if the end user, let's say business people who are going to analyze or make something of the data or logistic or HR and so on, if they are not aligned, like you said, and on board with like all those changes and no one use it in the end, this is like the same problem with data scientists. You can spend
Yeah,
months training the
yeah,
best model
exactly.
in the world. If no one use it, well, well, you have zero added value. Um,
Yeah, exactly.
and
I totally agree. And for me, there is a phrase I often use. So maybe it's not that clear, but it's to say, for me, MLOps, it's to build industrial system through artisanal means. What I say by that, it's what you expect from an MLOps system is to be industrial, to have something repetitive, reproducible, that scale well. And on the other end, people tell me, what should I use? Should I use SageMaker and this and that? And every customer is different. They have their background, they have their legacy, they have the skill of their people. Like, can give me 10 company, I will not recommend the same platform to each of them. It's that's the goal of the engineer. It's to understand, see what will be fitting. Like an example. When I work at ArcelorMittal, I made a mistake. It's my manager told me, okay, we need to have a system that's usable to data scientists. So I did, okay, two objectives for me: usable for data scientists and data analysts, and something I could experiment a lot on. I think at ArcelorMittal in 9 months, I have created like 40,000 model, because I was my key was to say, okay, they tried a lot of things. We need to try even faster so that we can build thousands of model every week, so that we can see what work and what doesn't work. But the issue I made was on the choice. I say we'll use notebooks for industrialization. At that time, we say, okay, there was some discussion, not as now, as you say, notebook, go make yourself. Sorry, but you can cut that if you want.
I
So,
won't.
all right, all right. So yeah, so the thing, I did a system on notebook based on paper mill, and
Uh-huh.
my manager told me, yeah, but what about best practices? I say, but you wanted something accessible, yeah, but we can have something which is accessible, but no, not following best practices. What we'd like is something accessible and that follow best practices.
Mm,
It's okay. There is, can it work? And say yes, you need to expand people's skills. And
yeah.
so in the end, the problem was not to have a system which was accessible. It's to what was the thing I should have done was to bring people and improve their skill. Say, okay, you don't know
Mm,
Docker, you don't know how to have the code base in Python.
mm,
Let's grow people's skills.
mm.
And that was a hard lesson for me, is to, because I had to recode it, and I didn't want it to miss, so I put a lot of energy to code it again in the right way. It's you always have this choice between having something maybe too simple, I would say, and something which is and not following best practices. I think it's better to grow people's skill. People want to grow, they want to learn more, so exploit that. And I know that at Decathlon, sometimes I'm working on the code templates. People tell me, Médéric, the template can be a bit hard because I'm using adapter design patterns and Pydantic and a lot of unit tests and fixture. And but you spend times with them. We have training. We are try to be as welcoming as possible to the user, and in the end, they end up liking it. So okay, unit test, okay, check, linting, check, and then you have a code base which is nice, people which are happy, and you have something which try to follow best practices as much as you can to avoid having to wake up people at night. And I think that's a win for everybody.
That's impressive. It makes total sense. When you said notebooks, were you speaking about Databricks in particular?
Yeah, so good thing. We are also using Databricks, and lots of the earlier stuff with Databricks was mainly run on top of notebooks. And for us was a big issue, but for me personally, because I
Okay.
cannot came back to Arcelor with my expensive notebook. I said, no, guys, you cannot do that. You cannot run unit test on notebook. You cannot run
Okay.
limiting on notebook. We should not use notebook. So
Okay.
it was not natural. Now, Databricks, they release a big book of MLOps, which I recommend for people who want to use Databricks. They release a lot of resources, but at the time, you really had to go through the API, and it was complex. So the thing I like with Databricks is that there is always this API you can use to automate stuff, which is key, I think. And we ended up doing our implementation of this concept on top of Databricks API, to try to have everything. But it requires a lot of engineering mind juice to have all the things we needed and not rely so much on notebooks. So now I think it's easier on Databricks to have this kind of workflows, but back then it was not that easy. So yeah.
Hmm. And then speaking more generally, like, so you explained that you could find different tech stack
Mm.
for like 10 different tech stack for 10 different companies based on their maturity, where they are with the business, the scale of the business, and so on. That being said, do you feel that there are some technologies out there that like if you implement them and you have a reasonable maturity in your data, you can make a bad decision? And by that I mean cloud computers, you can go AWS, GCP, or Azure. Then you have tools like Airbytes, Databricks that I can see in different places are like very common, but that's just what I have top of mind. Do you have a thought on that?
Yes, so yeah, good point. So it's so there is a lot of cases. So let me give you some. Some people, they come to me and say, Médéric, I want to use Kubeflow. Kubeflow is state of the art. I want to use Kubeflow, and I say, do you have already? Are you already some Kubernetes user, some engineer that can manage platform for you? Say, no, no, but Kubeflow we know from a blog, So I call that medium driven development. You see an article on Medium, you want to use that. And I say, yeah, but it's really too complex. So Kubeflow, it's made by Google. Google, they do some amazing product, but they also have something which are really tailored toward their engineer, no, not for the general engineer. So if you are a simple company, don't have a lot of people working on this, don't use Kubeflow, for example. If you just need to do a linear regression, few megabytes, don't use Spark, don't use SageMaker, just a notebook and maybe, I don't know, a Docker will be enough. So it's all of this, I think, again, come from first-hand experience. It's you have something that should be fine in theory, but in practice not so. Like, give you an example, in my career, so I struggle a lot to try to find the best MLOps platform. For several years, it was my objective to try to find the best one. So I tested several things, from the simplest one, from the hardest one. So ZenML, Metaflow, DVC. I tried Prefect, Daxter, you name it. You see this big poster with MLOps technology. You try all the thing, PatchDM, Argo
Yeah.
workflow. I didn't find any, and that's because it's most of the time when you have this kind of general thinking, you don't see the customer, you don't have the target, so it's difficult. And I think nowadays, if you, yeah, even now, I would say you could use SageMaker, Azure ML, or GCP. To mention, following this quest, I try to complete as much certification as possible. So I got the certification on Databricks, GCP, Azure ML. So SageMaker, I'm using it. We are using it a lot. So I say, okay, at some point certification are hard, so you don't want to have too much. But to compare everything, and yeah, they are all good. In 80% of the use case, I could say yes, it could work in your use case, but there is 20 where it will be a bad idea. So having general rules is always difficult. So a little joke. So you go on the if you want to become an MLOps expert, the thing you need to do is, when people ask you a question, you need to answer, it depends. That's the mark of a true expert. You say, I have this problem. What you need to do, and you say, it depends, because you need more context, you need more scalability, volumetry. So I work with the data architect at Decathlon, and same thing. I want that. First question, it depends. What do you have? And you go deeper into the requirements.
Hmm. What are the first three questions that you ask? Like, is it okay, volume of data, use cases that you have in mind to implement, and maybe, and like the inference, like how long does it need to take for the result to come up? Like, are those three that you consider first, or like what would be the first three questions if I come to you asking about an MLOps platform for
Um,
recommendation?
Actually, my first question will be, what's your workforce? What are the
Hmm.
profile in the company? Take a coffee with the people and say, okay, what do you work? What do you like? If somebody is telling you, okay, for instance, I don't know how to use a Cloud SDK, I'm just using Notebook. Throwing SageMaker at this person may not be the best thing. So,
Right.
or at least you can say, you can say you use SageMaker, but you need to find a buddy that will able to support him. A data ops, an ops people which have skill there, not necessarily good for modeling, but that's not a
Mm-hmm.
problem. It's to
Mm-hmm.
have someone which know how to use Terraform and know how to use this system. So the workforce, the price, the price, and the budget that you have in this sense. And the third thing, but that's because I'm European, is the regulation. If you are a bank, if you are a bank, you don't have the same requirement. Like when I work at the European Commission, getting to have things running on the cloud, it's a huge challenge. So, and the problem, I think, is running thing on premise is really challenging. I always tell, okay, can you SageMaker? And if you don't want, that's fine. You need to hire a 5 skill Kubernetes engineer, and they will do miracles for you. But try to find them, try to keep them, see how much they cost, and then reconsider if you really, really don't want to use the cloud, or if it's just a false requirement.
Right.
And after that, I'm asking about inference and
Okay. Yeah.
scalability. That's completely secondary.
That's
And,
awesome.
and yeah, and that's the thing. It's you. I love both questions, but I know
Mhm.
that people in the field, we love the technical things. We love to say,
Yeah.
okay, which instance I'm going to use, which NVIDIA cards. But it's not the most important question, I think, for
Right.
when you're tackling the, I want to have the best MLOps platform.
Right. Right. It's like, okay, I want to go there. Cool. Let me build you that plane. Yeah, but I don't know how to drive planes. Yeah, but here is your plane.
Yeah,
Okay. This is my okay.
yeah.
um Amazing. I have too many questions. I have too
Yes,
many
thanks.
questions
Up to
coming.
you. Up to you.
Um, all right. So you helped me reprioritize the questions I should ask. I understand clearly. Loved your insights on the tech stack and how you approach different types of problems. How do you go about state of the art? Always trying to understand how, like, which solution best implements it. I really enjoy this journey that you shared with us about just going for this. What is the best MLOps tech stack? And answer is there isn't. It depends. I love it.
Hmm.
All right. I think I would like to ask you maybe a few more questions. Um, the first one being when you go about when you at your work at ArcelorMittal.
Yeah.
Not sure if I pronounced it correctly, but you said that you trained 40,000 models. How would you go? Like, what are your insights about building pricing models, if it were pricing, I think, like, do you have some insights about pricing models? And I think you've also done a lot of fraud detection, so do you have insights on both those topics, like maybe shortcuts that you can share with us what you
Yeah.
learned through building all of those?
So I have a funny story. We so at ArcelorMittal, we had a creative teams, and people had a lot of insights. So what I realized is what was mattering the most for us is to test the hypothesis as fast as we could. For example, should we build one model per country, or one big model? Should we remove some feature or keep them? How should we structure our back testing strategy? So you see in pricing model, you need to compare you predict the future from the past. So you cannot just randomize everything, shuffle things, and it doesn't work like that. So how do you take into account, for example, holidays and other events? So a lot of question. And again, theory, practice. Sometimes I thought I had the best insight, which gave the worst prediction, and sometimes I had the worst insight, and it gave me the best prediction. I'm giving you the worst. So we really tried to beat up the system in place, which was involving a lot of human, in the loop, and people which know the field quite well. And at some point, I just created a dumb thing, a real dumb thing. I said, okay, let's add the year for the prediction. And I had a discussion, and people told me, but the year, Médéric, but it makes no sense. Like, we are in 2019. What do the model care if you are in 2017 or 2018? Because now, if you are in 2019, it's 2019. If you have a branching in your tree algorithm, there's no case in the future where we are in 2018. Not sure if it's clear, you see, but it's
Yeah.
and so I tried it. I said, okay, I just want to try. I just want to try. It doesn't cost me a lot to add a new feature. Let's try that. And it was one of the best feature. Say, why? And so you say, okay, I need to explain that. And my better theory was that it was a way of regularizing the model. Pricing tend to become outdated. It was a way to introduce a feature to say, this thing is outdated, put it into the trash can there. So okay, you say maybe it's just one, it's a luck, it's just luck, but we tried it. It was every time we were running that, and the year came up as really a key feature. And so yeah, so I'm not a time series expert, but it was surprising. But no, say if you say, okay, it works. So if it works, let's use it. And it was a good improvement over our metrics. So that's why it's I think you have this discussion on the show, generative AI, robot replacing us. Interesting discussion. I really love to listen your show for on this topic. So, but the thing is, it's really when you combine the power of human to have this imagination, this creativity, and the power of machine to do a lot of operation, that I think you have the best result. And for me, machine learning is that. I mean, I would somewhere at some point, I'd love to know someone, a data scientist, would tell me, I know this is going to be the best solution for you. I don't know. And every time what I found is people saying, okay, we just tried a lot of stuff. At some point, these things work. Let's do that. From a research background, that's also how it works. And so yeah. So I mean, insight is not to have a fixed list of things, is to have this dynamic mind flow, and combine that with a system that allow you to support this mind flow. If
Mm,
you are limited by the system, I think it's bad. Human, it's really the most limiting factor in our society today. It should
mm.
not be the machine, I think.
Yeah, makes sense. Like being able to from yeah, because the hardest part, sorry, from building models like either well now if we're including time series and pricing and so on, I feel it's just like taking the original data set, creating it, and then just creating features and features and features.
Yeah.
And so when you can automate that, you can do interesting things with time, hours, years, months. You can then derive the variables. You can do like sinus, cosinus, and like all kind of things, and that combined can at some point add up to a very interesting model based on the metrics. Do you want to share a little bit on the metrics that you used and and maybe like some key features around prices that you find interesting?
I don't want to disclose too much thing, and I think now they evolve from that. But coming to what you just said, it's in the MLOps field, I think one of the key aspects as well is to expose all of these possibilities, because I know that it's you have on one end data scientists which have not been exposed necessarily to design patterns and so on. They code something. It's really it does one thing and it does it well, but no, you want to do two things with that, it's
Hmm.
difficult. It's hard coded.
Hmm.
I watched some code base in my career. I saw I don't know where it's going. It's difficult, it's not manageable. And when you apply design patterns, you can really expose all of these with soft coding, with the factory patterns, the adapter patterns, and it's something that empowers people. So it's again this kind of thing that support build, testing the features, testing all the possible combination. To my students at university, I was telling them machine learning is just a bunch of for loops. You test all the possible model, all the possible parameters, all the possible data set, all the possible combinations. So it's a lot. So it's a lot of computation, and with human mind, you can cut through this number of loops to reduce the search space. But in the end, it's that, and yeah, it's and you need to expose all this possibility to the end user.
Amazing. Okay, so I'm going to ask you a few last questions, and I have
Okay.
a question from the previous guest of the previous
Oh,
episode for you. So we're doing this fun dynamic where
yes.
you're going to answer his question. But before that, do you want to share a little bit maybe your passion around coding in general? You mentioned uh, patterns, designs, and like best practices. I feel that we discussed so many trendy topics
Mm,
in these episodes, and I feel that the approach that you have is very practical and following first principles
mm,
around coding and patterns and so on. So, would
mm.
you have key lessons and takeaways for us to go and think about it? And maybe some resources that we should look into for everyone who is listening.
So I have so much thing that came to my mind. So um, uh, uh, just a bit of personal experience. I really love programming. I mean, I've learned C++, Java, PHP, Ruby, Groovy, Haskell, Clojure, Elixir, Erlang. So he language, the he language, it's a Lisp on top of Python. Really funny
Wow.
language. So many languages, and it's like being polyglot. There is things that you like, that you don't like. For example, I love the concept of modal in Haskell. I love I'm a big fan of Douglas Hofstadter. I never know the name. The guy who wrote Bash, Escher, and I have a blank. Bash, Escher, and sorry. The thing is, there is a lot of things in every language, like Elixir, or Erlang. For example, that WhatsApp was built by eight engineers working on the platform, and they were able to create WhatsApp with 1 billion people. So I think it's what I'm saying is it's by looking at it's really by looking at all these languages that I came up with this this toolkit in my mind when I say I can use this thing and this other. So I think it's really interesting to learn that. But I understand people don't have a day is 24 hours, so you have to you hit the limit. Some people they find it through music or from other activities. So um, it's it's uh, it's really a brain activity, I would say. And to answer your question, um, I think what helps overall and to have a really the key advice is try to look at open source projects. You can find, for example, what Flask is using for his LinkedIn, its organization or other projects. Try to know what's in the community. For example, in Python, which thing I've used. I could recommend, for example, there's tons of books, tons of GitHub repository. One which is interesting, I think it's called Python Gotcha. Or there is also what's the Huck Python, VTF Python to put it like this, and it gives you all the quirks in Python, like the thing that might surprise you. So yeah, at some point uh, I mean, several times in my career, I end up reading the Python documentation because I think there is a lot of things you want to learn. And yeah, you can go through coding challenges. You can go to I don't know, hacker project. That's the thing I like the most. And all of this will build your skills. And that's, for example, my wife told me I need to manage to parse some emails, put it in a spreadsheet. You say, okay, I'll do that, and you learn how to do that afterwards. So it's the sum of your experience. And I would say even for so it's three things: some of your experience, some of your errors. Errors are key in programming, and also looking online at resources. But I understand everything. You have 24 hours in a day, so yeah, it's to select what's really the most appealing to you.
Yeah, following curiosity. But that gives a clear. It's not the first time I hear about just reading documentation, and it feels a very powerful. I'm getting to it. I'm getting to it. Reading like Airbyte. You mentioned Flask.
Yeah.
There are many interesting things to read. Um, Awesome. All right. So I'm going to ask you. Well, I think this is going to be the last question before the two little questions, and
Okay.
then the well, previous guest on the show is going to ask you a question. So let's go into it. Um, you've mentioned every. I think we've covered many topics here. Um, I think. Okay, from an MLOps perspective, from a coding perspective, from a freelance perspective, I think we've had very insightful topics.
Mm.
So, where can people learn more about you? Do you share on LinkedIn? Do you have a website, a blog? Where can people learn more or contact with you?
So several places. If it's online, people can find me on LinkedIn. I share articles, so I don't try to spam people. But if I find something really interesting that we discuss in the MLOps community, for example, I like to share it. So there is a lot of good resource online. People can also find me on the MLOps community. I love to answer questions on Slack, and I think it's a good way to learn MLOps because there is not a course on MLOps, and it's by discussing with people that you find the best problem and the best answers. And if you want to find me physically, so I'm located in Luxembourg in Europe. I help run the MLOps, the local community. So if you are near Luxembourg, you are welcome to join one of our meetup. I think one of our next one will be with AWS to discuss about Bedrock for generative AI. So should be interesting. And yeah, and I have also a blog, and also if you want, so a bit of ad. I'm also coordinating the writer community on the MLOps community. So if you think there is an article that would be worth relaying on the MLOps community or our newsletter, again, feel free to reach me. I'll be able to review it and to help you share it to the community. So yeah, think yeah, all these places.
Awesome. So my last question before the guest previous guest question, I need to get used to to introducing this new concept. My last question is based on this episode, based on everything that we shared or not. It can be something totally different. What did you feel? that you could share? Like, what is your end message? Let's say it can be anything. It can be in this episode or not. You decide.
So the end message will be curious. But the thing is, I can understand that from listening to me, people might say, "Yeah, but I don't have the time to read Python documentation." I completely understand. I mean, it's really to find something that you enjoy doing through the way that you like. So again, coding competition, discussing with others. It's the best way to grow your skill. And if you don't grow your skill, it's okay. I mean, being a good human, it's important. I mean, it's far better, I think, to say I have nice experience where I can share with people, know their problem, bridge people together. And that's important. Some of my best managers were not the best technical people, but man, they were so good, at bridging people. So yeah, it's do something that you are passionate, and then the curiosity will go after, I think.
That's a powerful message because like you said, sometimes it can be overwhelming. Like when we want to make a first step. I'm speaking to myself here. This is a message for
Yeah.
me for later. But when we want to do a first step towards a goal, and then we are overwhelmed with the informations of which path we could take. But having these goals in mind where we're following our curiosity and we're just keeping taking actions through times, it is very empowering, and somehow we we adds up some skills that are unique, and I feel that the value comes from having unique skills that combine and have a cumulative effect over time,
If I may
compounding effect.
If I may share something on that, is when I was 20, one of
Hmm.
my main philosophical discovery was one people what wrote on the internet, you can see yourself what you want to become and see this huge gap between the final you and you, which is too much to this is too much for you to follow this path. But if you
Mm.
just say, okay, what can I do to be just a bit better, step by step, that helps a lot. So that helped me a lot in my career. And it's like also when you have to want to have to eat with your friend, at some point you say, okay, it's a big meal, but bit by bit, you can eat everything. So for food, for food is more pleasant, and we don't have the same kind of restriction. For coding and stuff, it depends on the people. So yeah, again, if you love eating food, that's easy for you to do.
This is an interesting analogy.
Yeah.
This is all right, and the guest questions
All
is,
right.
what is your favorite? And this is funny that I'm asking it to you because you have so many programming languages to choose from. But the question is, which is your favorite programming language and why is it Python? Which is
Oh no, no.
so
For me, it's Lisp. It's Lisp.
it's
I mean,
Lisp,
yeah, it's Lisp because
program.
yeah, when you again, I don't recall the name of the book, but please share it on your episode. So it's Lisp. I read Peter Norvig, for example, director of AI at Google, and other thing. I'm Lisp. When some people explain to you that the relation between
Hmm.
DNA and proteins is the same between Lisp code and program,
Mm.
it's like it's like mind blown. I mean, it's not a language I would use on my work day to day, but it was of the languages which I would say is you touch, there is type XKCD, the famous comic Lisp.
Yeah.
You get the picture. You have a comic saying universe was written in Lisp, and the end some people will tell you no, it's at the end it's some people that hack it in Perl. That's another episode.
That's awesome. I love it.
Yeah,
Yeah, and I think it's Paul Graham who have
yeah.
the creator of YC Combinator, who he was always
So,
been talking about Lisp. He's still talking about Lisp,
yeah.
and Lisp seems like an amazing language. And so maybe just to linger a little bit on Python, do you have a favorite Python package or like something that you really like about Python?
Um, Good questions. No, I think with Python, what I like is its simplicity. Because the thing is, when you are learning a language, I mean, all this we discuss, it's complex, and I'm sure all the guests in your listener, it's a complex topic. Bit by bit, you can have it as we discuss, but it's complex. And I think having a language which is so simple, we can we can leverage the whole C++ Rust code base to have something a simple experience. That's the key feature. So it's not a package, it's that, and so that you can focus on your problem, and the language is not another problem. Like I haven't learned Rust yet. But for me, the language is intimidating. It's good if you want to work on low level, but when you have to bridge training, MLOps, and all of this stuff, having a simple language, it's good, I think, for the brain to focus on what matters, I think.
Makes sense. All right, we're reaching an end of this episode. I want to
Yeah.
thanks a lot for taking the time to coming on the show, to sharing all your knowledge. I had an outstanding time. For everyone who is still listening, thanks again for being here and being interested in these topics. What we're doing here on Let's Talk AI is really trying to bridge those gaps that we mentioned in this episode, in terms of bringing closer the community and understanding better data and AI in general from technical perspective, but also from an entrepreneurship perspective, legislation, regulation, ethics, and so on. So if you enjoyed this episode, feel free to subscribe and share comments. I would love to hear some feedbacks on this episode. And that being said, thanks again, Médéric, for your time. I had an amazing time, like I said. Now we should have a wonderful day.
Yeah, and you too. And just if I may add, you have a wonderful podcast. I listened to several of the past episodes. So subscribe, register. Maybe you not do that, but on all your podcasts, and it's there are some really great episodes. So thanks a lot, Thomas, for what you are doing.
Likewise, have a great day.
You too.